I hope this is working. Something changed different. Okay, Santino, you're live. Input, say it. Okay, one squared, two squared, negative one squared, negative two squared. That's the input output. Everyone should have got that as a picture. The idea today is we're going to go into what is actually 1/6, but you won't see that. I have a worksheet for you. And the idea of doing transformations and how this picture right here is a quadratic. So it will be the same as this picture to the left, but shifted and maybe stretched, maybe reflected, so on and so on and so forth. So that's the idea why I have the notes constructed. That is why I had you fill in that thing. And I told you, like the first 8 graphs, you need to lock those in that this is what these will look like. So all x squareds will be parabolas of some sort. This is the parent. These are the babies. All right, and they are like the parent, but they have differences. Santino, what could I plug in? By the way, input output. That's what we're doing here. What can I plug in here to make the set of parentheses 0? You are correct. And actually, Santino, what I'm showing you is this is going to be the vertex. All right? And then we can say what are the transformations compared to the parent. By the way, Santino, what's 3 minus 3? You said it? 0 squared times 2 plus 4. 4. So that is why this is 1, 2, 3 right, 1, 2, 3, 4 up. Whatever makes the parentheses 0 on the inside, that's your right-left shift. So what would you say, Santino? Did this move 3 right or 3 left? So it moved 3 right, 3 right compared to who? The parent. This vertex got moved 3 right, and then how much up? 4 up. So what I wanted to get in this section right here is this is how we see the changes. Really the 0 of the parentheses makes this happen. And then, you know what, Santino? I'm doing this with my math tours right now. Why did I pick 4 and 2? They're both 1 away from the vertex left and right. Let's plug in 4 is easier. What's 4 minus 3? What's 1 squared? 1 times 2. 2 plus 4. Guess what 2 comma is going to be? Look at this. Huh? 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 So I have 3 comma 4 and then I have 4 comma 6. So what do you think is going to be 2 comma? Ooh. Ooh. Okay, this is the vertex. This parabola is going to be going up. So 2 comma 6. That's how we do it in math 2. We understand that this is going to be a parabola, so there is that let's say symmetric point right there. Okay, so notice what this 2 did, and then we can come up with an idea there. Maybe we notice it, but let's get somebody else. Santino has done a heck of a lot. Hey, 16, nice. That's Dylan. What do you think that 2 did to the parabola? Watch this, first of all. Rise 1, run 1, right? You see that to that next point, but then this is a little bit higher. Doesn't have a slope like a line, but we can really count that on the first set of points. And then notice this. Rise 2, run 1. That's what that 2 did. So what did that make it? Did it make it skinnier or wider? Skinnier, but we don't say that. We say it's stretched. Because not all graphs look skinnier when they're stretched. That's true. So it's stretched vertically by a factor of 2. That's what the 2 on the outside is. So, hey, look at that little half sheet. No, actually 1/6 of a sheet. Look at those things right here. Now I want to reference this right now. Those that are at home, this is what I'm showing them. Ooh, take a screenshot of that if you're not here. Okay, notice the first one, f of x, and then plus c on the outside. That's what Santino had. He had a plus 4. And then notice what that says. That's up 4 units. That's why I like this. I actually stole this off the internet. And then look at this one. This says x minus 3 on the inside of the parentheses. So that is the 4th one on your sheet. X minus c on the inside. That's c to the right. Got it? You see what's going on here? And then there is that C in front. They like using C down at the bottom, the second to last thing. That is a stretch when it's greater than 1. So vertical stretching. See that right there. So that's why I gave you this little sheet so you can recognize these changes and say what they are compared to the original. All right, Dylan, I only asked you one question, so I ask you two more. What's the domain? All real numbers. And then what's the range? Bracket 4, infinity. Awesome. And then I can move on. And this actually tells me that we don't have a problem with Dylan, and I hope everyone else understands that that range is what it is. And he said bracket, like, so that was so specific. Awesome. Let's move on. Now, I hope the next person gets this down. What's happening here? What we're going to play. Hey, Santino. This is amazing. What am I going to plug in my chart, do you think? What am I going to start with? You are correct, and you got it down what I gave you in the last thing. Because then you'll see that this isn't a vertex, but the key point for a cubing function is where does this point go? You know, that little flattening out point. That's like the most important point. And it's going to be at -1 comma. You know, the 0 of the inside of the parentheses. What do you get when you evaluate? Oh, no, you're going to have a fraction. You know what you get? Are you good with evaluating? Oh, it is -2. It's not that bad because the half is okay. So -1, -2, it actually wasn't that bad at all. -1 down 2. So what are your transformations? You'll see this behavior after we graph this. Left or right? Left 1, down 2. And I'll prove it when we graph the rest of this. Then we'll see the what that 1/2 does. So I like this thing. It actually really hammers down the left-right thing. Left 2 when it's +1? Yeah, it's because it's whatever makes this 0. So that's what's happening there. Okay, and then here's Santino. We're actually going to plug in numbers that work nicely, like 1 plus. I guess 1 is nice because what's 1 plus 1? I don't want to plug in 0 because then I'll get a fraction. No one likes fractions. So I'm going to plug in 1. You get 2. What's 2 cubed? 8. What's half of 8? Let's take care of that first. So it's -4. Then what's -4 minus 2? -6. So 1. Sorry, I couldn't think. And then 1, 2, 3, 4, 5, 6. And then I should flip to the other side of this. -3. Now, be careful. Oh, wait a minute. This point, then this is down here. Oh, it's because I have a negative out in front. What did it do? It flipped it. So what do you think you're getting at when you plug in -3? Well, we better plug it in. What's -3 plus 1? It's -2, but then cube it. It's -2. -3 plus 1 is -2. It's -8 times -1/2, though, is what? 4 minus 2 is what? 4 minus 2 is what? 4 minus 2 is what? 2. All right, so sorry, it's not like a reflected value because here's what it is: 1, 2, 3, 4, then over 2. 1, 2, 3, 4, then over 2. There's that odd symmetry, but that's where I get -3 comma 2. So again, this input-output, what I am doing is PEMDAS. You better write this down and follow those rules when you're evaluating. That's what I'm making Santino do. What did I do first? I plugged in -3. I did the exponent. Then I did the multiplying. Then I did the subtracting. The only reason you cannot evaluate is because you cannot follow PEMDAS. So you need to write it and follow it and get those points. Okay, so Santino and everyone else, I think I already said this, that this is reflected over the x-axis. Look at this picture. Now it's going in the opposite direction, like if we did the end behaviors on this. And I do have on the sheet, I do want you to do end behaviors and all that, but we just won't do it here. But as x goes to infinity, now y goes to -infinity. As x goes to -infinity, y goes to +infinity. And those are the things that you'd have there. So reflected. And then the only thing that I ignored reflected over x-axis. I should have numbered these on this sheet so that I could reference that little sheet that I have here. And then the 1/2 is vertical shrink. This is, it's probably hard to see here when I have this graph the way it is, but this is supposed to be shrunk a little bit more wider. I should have come through and then widened it out a little bit so we don't see that. But that's what the 1/2 does. And that's the C value right here. When it's between 0 and 1, it's shrinking. All right, so we do have to kind of write that as well. The negative reflection over the x-axis is right here. 1, 2, 3, 4, 5, the 6th thing on our sheet here. Okay, so those are the things that we need to understand. All right. Yeah, I may have you graph this at least in this format. Ooh, I don't know what I'm doing here. There we go. Enter. Would have been Santino again. Nope. Nice. Joseph, you back there? Good. Okay, so the 1 over x function. You got these asymptotes. Now let's put it all together here. You know, there's an asymptote at x equals 0 because x cannot equal 0. But that's why we have a vertical interruption. So we have to get that. Where is your asymptote going to be now, Joseph? Or what number could I plug in for x that gives me 0 in the denominator? 5. So this means 1, 2, 3, 4, 5. 5 is the vertical asymptote. Okay? And then what did we just learn in the last two things? What does a +3 on the outside do? What does that move a function? Is it up, down, right, or left? Let's look at the first one, Joseph. Look at this +4. What did that +4 move the parent function? For which direction? Okay, we actually wrote it, Joseph, on here. This is why we have to, follow along with previous examples. What does that say? 4 up. Okay, so what does this do? Tell me. 3 what? 3 up. Now, if I'm moving this 3 up, who does it really move? Sure, it moves these curves, but it actually moves this horizontal asymptote. All right, and that's really the key. So now we have a vertical asymptote at x equals 5 because of the moving right 5. We have a horizontal asymptote at y equals 3 because of the up 3. Over here, the VA was x equals 0. The HA was y equals 0. There's the differences with this one. Okay, and that's what we need to kind of see in this format. Oh no! What else happens with this, Joseph? What's a negative do? What is a negative on the outside of the function? And that's the previous question. What does that say right there? Reflected over the x-axis. So you're going to see a flippage of this graph. Okay, it's going to be, the curves will be inverted. So y equals 3, 1, 2, 3. And instead of up here, the graph is going to behave down here to those asymptotes. Instead of down here, the graph will be up here. And then if we had time, we'd look at the graphing calculator to see that this would all be true. Okay? So we don't input output on this one. What we want to find with these reflections and transformations is where are our asymptotes. I could very easily plug in stuff, but we won't on those. All right? You'll see when we do graphing of rational functions, all the first steps are finding your asymptotes. Then you're going to go to the graphing calculator. Okay, but hopefully you understand those transformations. 5 right, got a minus on the inside. 3 up, and it's reflected over the x-axis. Shoot, did I forget domain and range in the last one? I did, didn't I? Sorry, go back up to that. What's the domain, everybody? 3, 2, 1. What's the range, everybody? 3, 2, 1, because it's the same. It's all real numbers. So I forgot about that one. I just remembered that. Now let's go to the domain and range here. Sorry, I coughed during that infinity. Got a little something tickle in there. Okay, you know domain issues with this. It's the vertical asymptote. That's supposed to be a negative infinity. Sorry. The vertical asymptote interrupts the domain. The horizontal asymptote does, in fact, interrupt the range. And then you can name a whole bunch of other stuff. Like someone at, oh, this is good. This is good. Intervals of increase or decrease. First of all, what's my hand doing? Increasing or decreasing? Increasing. But what's it doing again? So some might say it's increasing from infinity to negative infinity. You can't say that because there's that 5 interruption. So you have to say it's increasing from negative infinity to 5, and then 5 to infinity. You do have to break it up. Right, so I was thinking about that in Compass. Someone asked me about how do I name increasing behavior on this. You do have to have that interruption. All right, next one. Oh no, this is the worst one. The worst. Look at your little shaded sheet right here. Look at the last thing. It says f of c times x. The c is on the inside of the function. That's what you have right here. That 4 is on the inside of the square roots. So what that is considered is a horizontal stretch or shrink. Notice what it says here. When c is greater than 1, it's a horizontal shrinking. Shrinking means pulled towards. Right? So this will be pulled towards the y-axis, compared to this parent function. And we'll see that in this actual question. But we should, yes, we should, be able to say what those transformations are first. Student number 19, which is Kennedy. What does that plus 5 do to the parent function? I'll give you a multiple choice, right, left, up, or down. What does that plus 5 do? Left 5. What does the minus 2 do? Down 2. Kennedy, we actually are going to plug in points on this one. And the point that we can and will plug in is that negative 5, that left 5 thing. And actually, I'm wrong. I want this one up at the top because this is not a like a vertex. This is the only starting point. Order of operations. What's negative 5 plus 5? What's 0 times 4? What's the square root of 0? Negative 0 minus 2 is what? So you get negative 5, negative 2. There is the left 5. 1, 2, 3, 4, 5, down 2. Oh, I thought I lost my pen. So there's our transformations, and she was already able to tell me that after 3 examples. And that's what you need to do and understand, when we look at our worksheet. But then also understand, where do I start my chart if I'm going to do a chart of values? And I did that in 3 of the 4 examples. Now, Kennedy, can I plug in negative 6, negative 7, negative 8 in this square root function? Yes or no? What do I get if I plug in negative 6, negative 7, negative 8? What kind of number? An I number, and that doesn't graph. So I have to plug in, is negative 4 good? It is. What happens when I plug in negative 4? What do I get? Well, let's go through it. PEMDAS, you do parentheses first. Negative 4 plus 5? 1 times 4? What's the square root of 4? Negative 2 minus 2 is what? Negative 2 minus 2 is what? Negative 4. So negative 4, 1, 2, 3, 4. Negative 4, 1, 2, 3. Oh, no. That's weird. Oh, that's because what does this negative on the outside do to the function? Reflects over the x-axis. Reflect over the x-axis. And that's what I see. I see my starting point, and then I see my next points going down. Let's do one more coordinate that's nice. You should be able to figure this out, but I think another nice one would be like negative, let's make sure. So if I plugged in negative 1, which would be right here. So what's negative 1 plus 5? Yeah, that's good. 4. What's 4 times 4? What's the square root of 16? Negative 4 minus 2 is what? Works out nice. Negative 6. So I plugged in negative 1. I picked a nice number to get me a nice evaluation. So negative 1 comma negative 6. 1, 2, 3, 4, 5, 6. Now, you are going to have to name this, but it may not quite show up. But here you go. Here's this flipped over the x-axis, and then it's moved right or left and down. So that is this piece. But notice this coordinate. This coordinate is not here. It's like pulled. It's pulled towards the y-axis. So that's why in theory this is always the hardest thing. This is a horizontal shrink because it is pulled towards the y-axis, and it's a horizontal shrink by 4. By a factor of 4 is how you would say that. Well, some people would say by 1/4. That's where it gets a little crazy. This book really kind of, or this concept here is really very specific that they say by 4 instead of 1/4. So a little tough there. Okay, here we go. Domain and range, student number 26. Nice. What do we have? 28. So is that Lucas? Lucas, what's the domain? What's our limitation on the domain? It's actually where Kennedy had to start. And then to what? You are correct. Couldn't plug in anything smaller than -5. And then what's the range from the picture that you see here? What y values are covered? Careful on your order. Remember a number line order. Ooh, okay. It is -2 as part of the domain or range. I'm sorry, but what else? Numbers greater than that or less than that? What number is way down here for y? So that's the order that you have to do it. -infinity to -2. Okay, so we really got to get this range by looking at a picture and then put a bracket on that. And then you can name some other stuff. What's my hand doing right now? Increasing or decreasing? So the interval of decrease is from -5 to infinity. All right. I guess you could say it's bounded above because it stops there. All right, exponential function. Boom. Oh no. Okay, so 2 more, right? Is this the 2 more here? Good. Okay, I'm going to rewrite this for you here, whoever comes up. And by the way, I did go crazy with our names of functions. It doesn't always have to be f of x. I think I named them everything different here. It doesn't matter. But this is the way you have to look at this. You have to take out that -1, and then this turns into x minus 3. Because I'll tell you why. Let's go right to our chart of values. Let's guess students. Oh, enter student number 19. Nice, Kennedy. What number makes the original set of parentheses 0? What could I plug in for x? 3. So what I'm trying to tell you is this does go 3 right. Because you see a positive 3 is that starting important point. And the important point for an exponential is what makes the power 0. All right, and that's what I really have to hammer down with you. So now that I rewrote this, pulling out that negative, then you see the x minus 3, that means 3 right. Okay? Now, what is 2 to the 0 power? Be careful. You know that? We did say it yesterday with 2 to the 0. I couldn't hear you. What, did you say something? No. 2 to the 0. Anything to the 0 power is what, everybody? 1. We got to remember that rule. It's been said many times in this class. Lock it in. So 2 to the 0 is 1. What's 1 plus 4? 5. Now, why is that not 4? I'll tell you in a minute. 1, 2, 3, comma 1, 2, 3, 4, 5. Here's what you need to know about the parent. The parent function has an asymptote at y equals 0. But Kennedy, what does the plus 4 do? It moves the function what? Up 4. So now this has a horizontal asymptote of y equals 4. 1, 2, 3, 4. So Kennedy and everyone else, this is what you need to know. First of all, we got to lock in that 0 power rule. Anything to the 0 power is 1. It's a prerequisite of knowing your exponent rules and knowing that situation. But the point that's moved 3 right and 4 up is that one. That's the most important point for an exponential, the 0, comma 1. This is the 0 power rule. Oh, the stupid pen. I have to write letters 3 times before they actually write. Okay, sorry. Speaking in tongues here. All right, so that's where that 3, 5 ends up. So yes, it is 3 right and actually 4 up. Don't get confused with that 5 value for the y coordinate. If I am at 1 for a y coordinate, it's 4 difference to get to 5. So it did get moved 4 up. Okay, any flips on this, Kennedy? Yes or no? No. But, oh, yeah, actually there is. I'm sorry, my bad. What does that -1 do? Well, we're going to see. We're going to see through our plugging in points. So actually what I'm going to plug in next is 2. I think 2 is nice. What's 3 minus 2? 1. What's 2 to the first power? 2 plus 4. Answering all those questions perfectly. 2 comma 6. Oh my gosh. Where are we at now? Oh my goodness. This is happening every day. Oh, okay. Half the class again. Okay. So, oh no, look at that. So when I plug in smaller and smaller numbers, we're actually getting this over here. All right. So actually, and then we'll plug in 4 real quick, and I'll do it. What's 3 minus 4, everybody? 3, 2, 1, go. What's 3 minus 4, everybody? 3, 2, 1, go. Here it comes. -1. What's 2 to the negative first? It's 1/2. 1/2 plus 4 is 4.5. Ah, there's that asymptotic behavior. This graph is actually doing this. So what did that negative on the inside do to this graph? It flipped it over the, say it in 3, 2, 1, go. What axis is this? 3, 2, 1, go. Y-axis. That negative on the inside is a y-axis reflection. All right, and now look at that on your sheets. Okay, you have this the 1, 2, 3, 4, 5th thing on your sheet. F of -x on the 5th thing on the sheet is a y-axis reflection. On YouTube, freeze the video and take a look at that. Okay, Kennedy, poor Kennedy got 2 questions here. Don't you feel alive though, Kennedy? Say yes. Victor, that sounded very energetic. Victor, what's the domain? It is, correct. Better be careful on the range. What's the range? Look at my hand up here. Anything exist here for the range? Nope, so it's 4. But what do I have on 4? A bracket or parenthesis? Oh, the idea of an asymptote is it's approaching, but it never gets there. So we need a parenthesis, actually. So make that correction there. All right? Okie dokie. All right, now the last thing. How many people are actually doing their homework during all this? Oh, wow, nice. The very last one, you're going to use your graphing calculator, okay? All right, absolute value functions. Let's get a student and go from here. Boom, shakalaka. Student number 11. Nice. Ethan, are you ready? Ooh, sounded very energetic. Absolute value of 1 is 1. Absolute value of 2 is 2. 0, 0. Absolute value of -1, -2. I should see those dots. That's what an absolute value looks like. We hopefully remember B. All right, that's what the picture looks like. Okay. All right. Let's try to break this down before we even do it. Ethan, what would the negative do to that V on the outside? Over? Oh, it's on the outside, so it's actually reflected over the X. It'll just be upside down. Let's make it simple right there. What does the 1/4 do? Stretch or shrink? Shrink which way? Vertically or horizontally? Oh, it's vertical. It's on the outside of the function, so it's a vertical shrink by 1/4. Let's get like real efficient in our writing here. That's okay. All right, next. What's the +3 do? 3 left, and then what's the -4 do? 4 down. If I were going to do a chart of values, I would plug in -3 to prove this. What's -3 plus 3, Ethan? 0 times -1/4 is 0. What's 0 minus 4? So that's the point. That's the idea. 1, 2, 3, comma 1, 2, 3, 4. This point got moved 3 left and 4 down. And that's what you can expect, your expectations of where the V is going to be. And it's going to be upside down, and it's going to be compressed. And we're going to prove that by plugging in some nice points. Like, you know what I'm going to plug in? I'm going to skip. I'm going to skip to 1. Why did I do that? Because of the fraction. What's 1 plus 3, Ethan? Just 1 plus 3. 4. What's 1/4 of 4? This is why I did this. What's 1/4 times 4? What's 4 divided by 4? Everyone hates fractions. 1. Negative 1 minus 4 is what? What's negative 1 minus another 4? Negative 5. So I have 1, comma, 1, 2, 3, 4, 5. Ah, that's the V. It's going to be like this, though. Shrunk vertically, compressed. All right, like that. And then the other point I'm going to plug in is for the other way, negative 7. Why? What's negative 7 plus 3? Negative 4, but what's the absolute value of negative 4? 4 times the fourth is 1. What's negative 1 minus 4 yet again? So there is that V situation. Here's negative 7, comma, negative 5 as well. That's why we have a V that's compressed like that. And that's how we do it. But we got to be able to evaluate, folks. I mean, we got to be able to deal with numbers here, or else this isn't going to go very far. All right, let's get that last person. Last one of the day. Boom shaka, boom shaka, boom shaka. Lucky number. Ryan, nice. What was your brother's name again? Brandon. I can't believe I forgot. Brandon, you're getting a mention 2 years later. All right. What's the domain? Absolutely. Better be careful on the range. What's the range? Yeah. Hold on. Careful. Nice. Good catch. Now in this one, does it include negative 4? Yes or no? I heard a yeah. I'm going to go with it. All right. In this case, negative 4 does exist as a point. It's right on our chart. Look. I almost called you Brandon. No, oh, sorry. It's right on the chart. So negative 4 is there. Okay. All right. So a lot of setup there, but it's important so that you understand these situations. Maybe one thing on the back of the sheet, you can write this down. Ready? I'm going to go ahead and condense everything that we hit, and I am going to put this on the internet if anyone wanted to read. At the end of the thing, they have this sheet, and that's why I wanted to give it to you as putting it all together. But on the back of this, put this down: y equals, and I'm gonna skip one of them. You know what? We're gonna call this f of x. This just means it could be anything. It could be anything. Oh, I'm gonna put a negative on the outside too. Negative a f of. Let's put a negative 1 times x minus, it's usually C and D that they use for this, and I just don't have a B. I won't put a B value in there. And then plus D. This is an x-axis reflection when it's on the outside. This is, when you look at this little sheet, this is called a dilation. And then on your sheet, it does say when A is greater than 1, it's vertically stretched. When A is between 0 and 1, that means a fraction. It's a vertical shrink. So that one's a little bit of annoying that we have to write that. This negative 1 on the inside is a y-axis reflection. Refer to, I think it was example number 4 that we had that. And then C is a right-left shift. D is an up-down shift. And that's how functions, all of them are affected. That's why I just put f of. It doesn't matter if it's a squaring, a cubing, an absolute value, an exponential, blah, 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 blah. They're all affected the same way. And I just proved that with 6 of them. Okay, that's a mouthful. All right, so she's probably almost done with her homework because she knows what she's doing. That's awesome. But look at your worksheet now. You should not be touching your graphing calculator once except for number 7 on the worksheet. All right. So graphing with transformations involved. You should have a chart of values off to the side. For number 7, we should think about what are the asymptotes. But then number 7, that's the first time you touch your graphing calculator to get a sketch. Okay? And then we'll probably talk about number 7 tomorrow.